All right, let's dive right in. We're going to talk about one of the biggest hurdles in machine learning today, which is how you take these amazing models you build in a lab and actually get them out into the real world where they can do some good. This is all about that journey from the notebook to production.
So picture this. You did it. You wrestled with the data, you trained a killer model, and wow, the accuracy in your Jupyter notebook looks incredible. But then comes that question that every junior analyst faces. Now what? How do we actually make this thing do something useful for the business? Here's the tough reality. A huge number of machine learning models just never make it. They never actually deliver any business value. They end up living and dying right there inside a notebook. And the reason, it's pretty simple, but it's a huge challenge. Deploying them and making sure they work reliably out in the wild is a massive operational lift. And that, my friends, is where MLOps enters the chat. The best way to think about it is as a bridge. It's the bridge that takes your experimental model and turns it into a tough, production-grade system. It's a mix of machine learning, software engineering, and data know-how, all working together to make our models dependable and efficient. Okay, before we even dream about deploying a model, we have to talk about data. It's an old saying for a reason, because it's the absolute truth in ML. Garbage in, garbage out. Having a solid data foundation isn't just a nice to have, it is, and I mean this, everything. This quote just nails it. You could have the smartest, most complex algorithm on the planet, but if you're feeding it bad data, your results are going to be completely worthless. That's why step one, the very first step in any good MLOps pipeline, is always, always, always about validating your data. So how do we actually enforce that quality? Well, we use something called a data schema. Seriously, the best way to think about this is like a blueprint for your data. It's a strict set of rules that says exactly what your data must look like. What columns you expect, what type of data is in them, are the values in a reasonable range. It's our first line of defense against chaos. And having a good schema pays off immediately. It helps us catch all sorts of nasty problems automatically, things like a single batch anomaly, where suddenly a key feature is just missing from the data feed. Or maybe distribution skew, which is where your data slowly starts to look different over time. But there's one problem that is incredibly subtle and, frankly, pretty dangerous. It's called training-serving skew. To really wrap our heads around training-serving skew, let's step away from the code for a second and head into the kitchen. Trust me, this simple recipe analogy is going to make it all click. Imagine you're a chef. Back in your test kitchen, that's our training environment, you create the perfect cake recipe. It's amazing. You use sugar. But then you send the recipe to the restaurant to be made for customers. That's our serving environment. Somewhere along the way, there's a typo. The recipe now says to use salt instead of sugar. The steps are all the same, the baker's the same, but that one tiny change to a single ingredient, it absolutely ruins the cake. And that is training-serving skew. It's when the data your model trained on looks, even in a small way, different from the live data it sees in production. Maybe a feature was calculated just a little differently. Maybe the units changed from feet to meters. These tiny differences cause your model's performance to totally tank, just like that salty cake. So how do we stop this from happening? The modern solution is something called a feature store. The name's a bit technical, but just think of it as a central, organized pantry for all of your data ingredients, your features. It makes sure that the test kitchen and the restaurant are pulling from the exact same pre-approved ingredients every single time. Now, this pantry is cleverly split into two parts. You've got the offline store, which is like the giant bulk warehouse in the back. It holds huge amounts of historical data, which is perfect for training our models. Then you've got the online store. This is like the chef's small prep station right on the line. It holds just the freshest, most up-to-the-second data, ready for making lightning-fast, real-time predictions. Now, one of the most important jobs of that offline store is to guarantee what we call point-in-time correctness. It sounds complicated, but all it means is that it prevents your model from cheating by looking into the future. It ensures that when you're training on data from, say, last year, you're only using the information that was actually available back then. No data leakage. Okay, our data foundation is rock solid. Now, let's talk about the actual process. See, MLOps isn't just one thing you turn on. It's more like a journey of automation. You can think of it as climbing a maturity ladder, where you go from doing everything by hand to having a fully automated scientific operation. So at the bottom, you have level 0. This is the classic data scientist lab. Everything is manual, everything is run from a notebook. Then you climb to level 1, where we build an automated pipeline for continuous training. Think of it like an assembly line that automatically retrains your model when new data comes in. And the top of the ladder is level 2. This is full-blown CI/CD, continuous integration and continuous deployment. It's like a self-improving factory where any new code can automatically trigger a whole new pipeline to be tested and deployed.
And now we get to the really exciting part, going live. Your automated pipeline is humming, the model is ready. But you can't just flip a switch. That's way too risky. We need smart, safe ways to roll out our new model without breaking anything. There are a few key strategies here. First up is canary deployment. This is where you cautiously send a tiny bit of traffic to the new model, kind of like the old canary in a coal mine. Then there's blue/green deployment, where you have two identical environments. You run the old and new models side by side, and when you're ready, you just flip a switch to send all the traffic to the new one. And finally, there's shadow deployment. This one is really clever. The new model gets real traffic, but its answers aren't shown to anyone. It lets you see how it performs in the wild without any risk. This chart gives you a really clear picture of how a canary deployment works. As you can see, the vast majority of users, 95% of them, are still using the old, trusted model. But we're diverting a small 5% slice of traffic to our brand new model. This lets us watch it like a hawk, check its performance, and make sure everything is okay before we gradually increase that percentage to 100. But here's the thing. Deploying the model is not the finish line. Not even close. Once your model is out there, your job has really just started. The real world is messy, it's chaotic, it's always changing. And that's why continuous monitoring is your final and most critical safety net. And the big bad wolf we're constantly watching for is something called concept drift. This happens when the world itself changes. Just think about a model that predicts what people will buy. It's trained before a big holiday season. Well, after the holidays, people's shopping habits are completely different. The old patterns don't apply anymore. The model's predictions get worse and worse. Monitoring helps us catch this drift early so we can retrain the model and keep it relevant. So to actually build all of this, you're going to need the right tools for the job. The world of MLOps tools is huge and can be a little overwhelming, but the key is to just pick the right tool for the scale and the specific task you're trying to accomplish. Let's just look at two really popular open source choices. First, you've got MLflow. It is absolutely fantastic when you're in that experimentation phase. Its superpower is keeping track of everything, every experiment, every parameter, and organizing your models in what's called a model registry. It's like a superpowered lab notebook. On the other hand, you have Kubeflow. This is a beast built for huge scale. It's designed to run on Kubernetes, which is the industry standard for managing massive applications. You reach for Kubeflow when you have really complex multi-step pipelines that need to run across a whole fleet of machines. So let's wrap up with this thought. A machine learning model, on its own, is like a really powerful engine. But an engine sitting on the floor can't actually take you anywhere. MLOps is the art and science of building the rest of the car around it. The wheels, the steering, the safety features, the dashboard. To turn that raw power into something reliable and useful. So the question to ask yourself is, you've built a powerful engine, but have you built the right car around it?